left off. Find the image of the line y equals negative 2x plus 1. It's under a translation of negative 1 and 2, so going back to lesson 1, translations, but then also a reflection after that in the line x equals 1. So we're meant to do that, and we're meant to state the equation of the image line. So this is like a combined transformation. It's a combination of a translation and a reflection. So it's a little bit tricky, this one. So what we might want to do is, first of all, let's do the translation. Well, actually, to be honest, we need to also draw the original line. So let's draw the original line. We've got the y-intercept of positive 1. So y-intercept of positive 1. And the gradient is negative 2. So rise equals negative 2. Run equals 1. We need to go down 2, across 1, down 2, across 1. Down 2, across 1. Down 2, across 1. Up 2, across 1. Up 2, across 1. Yep. Down we go. Kind of more like that. There we go. Nice. And we can call this one y equals 2x plus negative 2x plus 1. So that's the original image line. Now what we need to do is, you might want to use a pencil, something erasable, because first of all we've got to do a translation. So we've got to do a translation of negative 1 and 2. So let's do that to each point. This is not the image line we're producing, because the image line then has to be produced by the reflection of the translated line across the line x equals 1. So let's first of all do it in green then, just to show it's an intermediate kind of line. So we're doing this translation, so remember it's horizontal and then vertical. So horizontal because it's x then y, horizontal then vertical. So we need to go back 1 and up 2. That's what that translation vector is telling us. We're going back to the left by 1 and we're going up by 2. It's a positive vertical movement and it's a negative horizontal movement. So back by 1 across 2. So let's see the first point I've got plotted, go back by 1 and up by 2, back by 1 and up by 2. The next point, go back by 1, up by 2, it actually just ends up being there. Next one, go back by 1, up by 2. Notice just by coincidence, it turns out to be the original line really, doesn't it? So it turns out, you might want to make a note, after the translation, the result is just the same as the original line. So otherwise, we would have to draw the new line. But because it ends up being just what the original line was anyway, when you do this translation, like see the next one, back by 1, up by 1, back by 1 comes here, back by 1, up by 2, sorry, back by 1, up by 2, and so on, ends up just being back to the original line. So that's not very exciting, but most of the time you normally would get a different line, but it turns out this just happened to be the same line. So now we're just going to do reflection in the line x equals 1, so reflection. So our mirror line is going to be at x equals 1, so that's a vertical line. So a mirror line through x equals 1, let's draw our dotted mirror line, and state the equation of the image line. So now let's start to plot the point. There is one point that happens to be on the mirror line, so that's also going to be a point on the image as well. So if you reflect it across, let's see the top one, the very top green one that I've got here. So if you kind of do its mirror image, it's going to be 4 units from the mirror line, but in the other direction. Same with the next one down. Instead of being 3 units from the mirror line in that direction, it's going to be 3 units from the mirror line in this direction. And so on. The next one down will match up with this one. 2 units from the mirror line, because remember that's the equidistant. 1 unit from the mirror line, and then we continue through. Following this kind of pattern. There we go. And now we're going to draw the line. Let's draw the line that goes through it all. Equation is what we're going to work out. So the image equation. Again, line, so it's going to be in the form of y And the y-intercept is -3. So you can see the y-intercept is just right here. It's easy enough. So the y-intercept is -3. So y equals mx minus 3. Now what's the gradient? So the gradient, you can see the rise over the run. Or you can use 2 points and you can just kind of like slip them in using the gradient equation. So gradient equals rise over run. And so you go up by 2, across by 1, you get a gradient of 2. What you could also do is you could choose 2 points on the purple line, so 0, -3, 1, -1, and you can plot it into the gradient equation. Remember, m equals y2 minus y1, the x2 minus x1. That's if the gradient wasn't as obvious as this one. This one is obviously a gradient of 2, so going up by 2, across by 1, up by 2, across by 1. So image equation is y equals 2x, and the gradient being -2, sorry, the gradient being +2, 2x minus 3. And now that's the end of the lesson. Thank you.